We are going to add vectors by using the head and tail approach. So let's start. At first, we'll go over this theorem. So in this theorem, the side of the triangle is A, B, and C. If this angle is perpendicular, then we can write C equals under square root A squared plus B squared. So basically it is C squared equals A squared plus B squared. Say, let us do some of the trick over here. If this angle is theta, then we can define sine theta equals B over this side C. We define cosine theta equals A over C. Then we define tan theta as B over A. Right? Those are the things these are the steps, these are the equations, trig equation we may need in future. So we can define sine theta, cosine theta, and tan theta. And one more thing is sine square theta plus cosine square theta equals 1. Okay. Let's go to the example 1. The goal is to add vectors A and B by using the head and tail approach. You may need the ruler and the protractor as needed. So my first vector is 3 meter due east. So I'm trying to draw 3 meter due east. Say, for example, it's that. Okay. So this is my vector A, due east. My vector B is 4 meter due north. Say, for example, I start this 1, 2, 3, 4. So this is 4 meter due north. This is my vector B. My goal is to add these vectors A and B. Okay. So I'm going to use the rule of head and tail. So I will pick one vector. So I'm picking the vector A for that. So let's use different color. So I will pick vector A and draw exactly same vector, same length, and parallel to vector A. So from previous videos, you know that this is the tail end of the vector. This is the tail end, and this is the head end of the vector. Okay, same will be true for vector B. This is the tail end. This is the head end. Okay, so now to use the head and tail approach, the tail of vector B should be over the head of vector A. So this is the again tail of vector A. This is the head of vector A. I need to put vector B such that tail of vector B and head of vector A will be at the same point. So look at here. This is the tail of vector B. This is the head of vector A. Okay. So the rule is this: if I join tail of vector A and head of vector B, that gives me the resultant vector or the addition total. So R in symbol we can write is A plus B. Be careful that this is a vector addition. So for example, if your vector A is, for example, 3 meter, in this we already give this number, so 3 meter, and this is our 4 meter. If you use the ruler, then this length exactly comes to be 5 meter. Okay, this is 3 meters, this is 4 meter, and this is 5 meter. For that you need to use ruler and the protractor. Okay, make sure that this angle is perpendicular, 90 degree. Okay, let's use the concept. for different angles. Say vector A making angle 30 degree north of east. This is vector A. Vector B is 4 meter at 55 north of west. So again, I will use the same concept that I did started before. So I will draw the vector A exactly same and parallel, say like this. So use the ruler and protractor again. So this is the vector A. You know that this is the tail end and this is the head of vector A, right? According to rule, I need to put vector B tail over the head of vector A, but you have to move parallelly and same vector. Okay, make sure that if I do vector like this is completely wrong. We don't do that. It's completely wrong. So exactly same B vector. So this is my vector B. Okay, use the ruler and protractor. According to the rule, if you join tail and head of this vector, this gives you the total, right? Total. This is the in symbolically A plus B, but this time that length may or may not be 5. It could be different. So you have to use the ruler and the protractor. So you have to measure. So the goal is use the ruler when you draw ruler and protractor to draw A and B. Okay. So that gives you the total vector or the resultant vector. That is called the addition. Same rule can be applied for if you want to subtract vector B from vector A. So let's do the same thing here. Say my vector A is 3 meter due east. So let's start from here. The vector A. And vector B is 4 meter due north. Okay, this is 4 meter due north. I want to find subtract vector B from A. So I want A minus B, which is basically same as A plus minus B. So clearly you know that if vector B is north, minus B vector will be south. So same length, but pointing towards south. So this will be your vector minus B. So the goal is to add A and minus B. So as before, I draw a vector A exactly same. This is my vector A. Then I need to draw minus B. Be careful that not B here because I want to find here A minus B. So from here, I will start vector B, vector minus B like this. So this is 3 meter. This is 4 meter. Again, according to the head and tail approach, you have to join tail of vector A and head of vector B. Okay, then you can measure this. So you have to measure this length and also record this angle. So measure length and angle. That's how you know the resultant. So this gives you resultant vector. Resultant vector means in this case A minus B. Okay, so you have to use the ruler and the protractor to find this. Okay, let's go to the similar problem here, but not like a east and west. So for example, vector A makes an angle 30 degree north of east. So this angle is again as before, this angle is 30 degree. and 4 meter, 55 degree north of west. So this is north of west, north of west. Okay, north of west. So this angle is 55 degree. My goal is to find a minus b, subtract vector b from a. So I want to find a minus b. So this is same as a plus minus b. So I want basically a minus b means basically a adding vector a and minus or the negative of vector b. So I start with vector a again as before. So I have to draw exactly same length and same vector. So this is my vector a. Now I want b vector, but not positive. It should be the negative. So if my b vector is this, my negative vector will be like that. Look at here. So I have to start a negative vector b from the head end of vector a. So this will be, you have to draw exactly same vector, negative b vector. So if you join head of first vector and tail of vector a and head of vector negative a, this gives you the resultant. We call it r. So r is basically a minus b. So again, you have to measure this. So you have to measure this, measure length, and measure the angle. Okay, that gives you the resultant vectors. We can use the online stuff also for that, like the OP physics, to get it make sense. So for example, if my length R1 is 3 meter, my vector B is 4 meter, then you clearly know that this length will be 5 meters. So for example, if I change the angle, look at here, then the resultant also will change. So for example, you can change the length. So for example, here, I change the length here, I change R2 here, then this length will be the resultant vector, okay? So for example, it is 4.48. If you change the angle, resultant will keep changing, okay? So look at that. So you have to play with this if you like. This is the great tool to play with, okay? So once you understand this concept, I believe that you can practice this problem, example 3, and follow the same step of the examples 1 and 2. Similarly, you can try adding factors a and b as before for the given vectors a and b. Similarly for the examples 5.